Hi guys, today we're going to go over a factoring process called difference of squares. So I'm going to give you a formula to start off with, and then we'll go through a few examples on how to use it. So first of all, what is difference of squares? Well, difference means a subtraction problem. So we're going to be dealing with a subtraction problem. Basically, two squares. So we're going to have one squared term minus another squared term. Okay. So a squared minus b squared, that's a difference of squares. What's the rule then? What's the formula if I have one square minus another square? When we go to factor that, we're going to end up with a plus b, a minus b. Okay? Make this parentheses a little bit better for you. Okay? This is the formula you need to memorize. Okay? So we know how to use this. A squared minus b squared, when we factor it, is going to equal a plus b times a minus b. If we want to check this, if you guys remember back when we FOILed, when we were multiplying binomials, we multiplied these first terms, then the outside terms, inside terms, and last terms. Hopefully y'all remember that. So if we're multiplying our first terms, it's a times a, which would be a squared. Okay? We're going to multiply our last terms. That's a times a negative b, so that's minus ab. We're going to do our inside terms, which is right here, which is a positive BA. It's multiplication, so you can reverse that if you want. So I'm going to put plus AB. And then finally, it's going to be B times a negative B, which would be negative B squared. Okay. You see I have a minus AB and a plus AB here in the middle. So those are opposites. So they're going to cancel out, and we end right back up with A squared minus B squared. Okay. So that's how this process works. But the formula we need to memorize for now is a squared minus b squared equals a plus b times a minus b. Okay, so let's go through a couple examples on how to work this. Okay, so here's our first example, x squared minus 4. Do I have a difference of squares? Well, first of all, let's ask the question, what makes one of these terms a perfect square? Okay, if we are dealing with a variable term like this, x to an exponent, our exponent has to be even. So if we are dealing with a list of x's, what x's are perfect squares? Well, x squared is, x to the fourth is, x to the sixth, x to the eighth. This would be a list of perfect squares if they are variables. If they're even, that means that we can multiply something by itself to get this here. So what makes up x squared? Well, x times x. What makes up x to the fourth? X squared times x squared. What makes up x to the sixth? X to the third times x to the third. What makes up x to the eighth? X to the fourth times x to the fourth. And this keeps going and going and going and going, okay? As long as your exponent is even with your variable here, you have a squared term there, okay? How about the numbers? How do I know if I have a square that's a number? Well, we'll start off with, here, I'm just going to give you a list of them real quick. 1, 4, 9, 16, 25, 36, 49. Now, where are these coming from? Well, 1 is just 1 squared, and 4 is 2 squared. 9 is 3 squared. 16 is 4 squared. 25 is 5 squared, and so on. I think you get the gist of it here, and those go on forever. Okay, so this is how we know if we have squares up here. Okay, do I have a variable term that has an even exponent? Yes. So I have a square there. Do I have a difference? Well, difference is a subtraction problem, so yes, I have a difference. How about 4? Is that a square? It is on our list here. Okay, and you might want to make a list of these to refer back to. Okay, 1, 4, 9, 16. Just so when you're working these problems, you can look back and see if that number is on my list of squares. Okay, if it is, I know I have a square. So yeah, x squared is on my list, 4 is on my list, so I do have a square. I have a difference of squares. Okay, so remember our formula was a squared minus b squared. Okay, so what did we multiply x? What did we multiply by itself to get x squared? Well, that was x times x, right? So in this case, our a would be x. Okay, I know that was a little confusing what I just said, but hopefully if you see it in action here, it'll make sense. How about 4? What was 4? That was 2 times 2. So in this case, our b is going to be 2. Now, what do I mean by that? Because a squared is x squared, right? And b squared is 2 squared, or 4. So you can see how we have a squared minus b squared, x squared minus 4. So our formula, x squared minus b squared, equals a plus b, a minus b. So in this case, if we were to factor this, we would get x plus 2, x minus 2. Okay, let's try another example. Example 2, what if we had y to the 4th minus 9? Okay, I'll pause the video for a second and try to figure this out first. I'll give you a few seconds, and then try it on yourself, and then hit play to continue. Let's see what you get. Okay, hopefully you took a second to work that out. Okay, what did I need for a perfect square in a variable term? I needed an even exponent. Do I have an even exponent there? Sure do. So that was going to be y squared times y squared is how I get y to the 4th. How about that number 9? Was number 9 on that list we had made out earlier? It was. And that happened to be 3 squared. So it was 3 times 3. Okay. So if we were looking at our formula, okay, a would equal y squared and b would equal 3. Okay, because a squared would equal y to the 4th and b squared would equal 9, and that's what we want to be able to put into that formula we had earlier. Okay, so remembering our formula is a squared minus b squared equals a plus b, a minus b. Okay, so we have our a squared minus b squared, y to the 4th minus 9. Now we just need to put our a's into our formula up there. So our a being y squared plus 3, y squared minus 3. Okay. Let's do one more example here real quick. Now I want to move on to another type of problem. If I look at an example that looked like this. 9x squared minus 100. Okay. Well, it's not as easy as the other ones because I have a mixed term here. I have a number and I have a variable term. Okay, but do I have squares? If I were to isolate each one, is 9 a square? It is. We already determined that before. And is x squared a square? It sure is because I have an even exponent. Well, what do I multiply by itself to get the 3x squared, or to get the 9x squared? 3x. Okay, because 3x times 3x is going to give us 9x squared. Okay. How about this number over here, 100? What's it a square of? What do I multiply by itself to go to 100? 10. Remember, 100 is on our list that we had made earlier, okay? Or if we had actually didn't make our list, but if we extended that list out, we would have got to 100. So here we know that our a is going to be 3x, our b is going to be 10. So if we were to factor that, we would get 3x plus 10, 3x minus 10. Okay. And this is for the case of checking our work. If we wanted to FOIL, we do our first terms, 3x times 3x equals 9x squared. We do our outside terms, 3x times a negative 10, that's a negative 30x. Our inside terms here, we get 10 times 3x, that's a positive 30x. And then finally, a positive 10 times a negative 10 is negative 100. You can see how these are going to cancel each other out, a negative 30x and a positive 30x. And that leaves us with 9x squared minus 100. Okay. So hopefully those few examples help on this part of it. Next, I want to go through a couple examples on when we don't have perfect squares there for our two terms. Okay, what if I don't have perfect squares in my binomial? What do I do? So if you don't have perfect squares to start, try finding a common factor in your two terms that when you pull that out would result in perfect squares. So let's look at an example. Say I have 45 x cubed minus 20x. Okay, 45, that was not on our list of perfect squares that we had to start with. Neither was 20. So what do? Well, let's start looking for a common factor. How about 2? Does 2 go into, well, no, 2 doesn't go into 45 because that's an odd number. How about 3? 4 plus 5 is 9, so 9 is divisible by 3. So 3 will go into 45. Does 3 go into 20? No, it sure doesn't. Okay. How about 4? Now we'll need an even number for 4 to go into, and this isn't even. How about 5? Well, 5 does go into here. Any number that ends in 5 or 0 is divisible by 5, so this is divisible by 5. And so is this one. So if we divided 45 by 5, that would give us 9. Is 9 a perfect square? Is that on our list? It sure is. How about if I divided 20 by 5? What do I get? 4. Is 4 on our list? Sure is. So let's start with that. So we're going to take a 5 out. And how about x cubed and x? Do we have perfect squares there? No, we don't, because our exponents are odd. 3 is odd and 1 is odd. Okay, so we need to pull something out of there that's going to give us even exponents. Okay, if I pull an x out, what do I get? X squared. So that works for me. And if I pull an x out there, well, then that eliminates that x, and we're okay with that too. That gives us x to the 0. We pull an x out of there, and for the purposes of difference of squares, x to the 0 will count as a perfect square. So let's look what happens. So we'll get 5, and we're going to pull out x. So if I pull 5x out of 45x cubed, what do I get? Well, I pull a 5 out of 45, I'm left with 9. I pull an x out of x cubed, and I'm left with x squared. Okay. We're going to subtract. I pull a 5 out of 20. What do I get? 4. I pull an x from x, and that eliminates it. So this is now what I'm left with on the inside. Okay. So I need to factor this. I have perfect squares here now. 9 is a perfect square, x squared is a perfect square, and 4 is a perfect square. So I have to carry my 5x down. I just can't factor that out and leave it. I have to keep carrying this down. So what goes into 9x squared to make a perfect square? Well, 3x. Okay, 3x times 3x is going to give us 9x squared. So that becomes the first term in our new set of new factored parentheses. Okay, how about 4? What do I multiply to get 4? 2. I'll get 3x plus 2 and 3x minus 2. You might remember it from before as a plus b, a minus b. Okay. So if that helps, but let's look at one more example. Okay, let's go ahead and pause the video now, take a minute to work on that for yourself, and then come back, push play, and see how you did. Okay, well, hopefully you've worked that out. So we don't have perfect squares to start, right? 72 wasn't on our list of perfect squares. 18 is not on our list of perfect squares. So we have to try to find a common factor that when we pull that out of both of these numbers will give us perfect squares. So what can I pull out of 72? Does 2 go into 72? Yes, it does. How many times? 36. 36, was that on our list of perfect squares? Yes, it was. What if I pull a 2 out of here? What am I left with over here? 9. Was 9 on our list? Yes, it was. So we are going to go with 2. It's going to be the number we're going to pull out. Jumping ahead of myself here. Okay, now let's look at our variable term. Okay, we have x to the 5th and x to the 3rd. Okay, what are we going to pull out? Here's a little trick I can teach you. If you've got variable terms that are raised to an odd exponent, pull out the smallest one. Okay, so we're going to pull x third out. Okay. So when we pull an x third out of x to the 5th, that's going to relieve us with x squared. That's a perfect square. When we pull an x cubed out of x cubed, that's just going to result back in our just our number. Okay, let's see what I mean here. If we pull 2 out of 72, what do I get? 36. If I pull x cubed out of x to the 5th, what am I left with? X squared. Okay. I pull a 2 out of 18, what am I left with? 9. And x cubed out of x cubed, and that just removes a variable term there. Okay. So now we have to keep our outside term here to pull that down. Okay. And we are going to factor our a squared minus b squared here. Okay. So what do we multiply by itself to get to 36x squared? Well, square root of 36 is 6, and then x. If we multiply 6x times 6x, we do get 36x squared. How about 9? What do I multiply by itself to get 9? 3. Okay. It'll be 6x plus 3, 6x minus 3. But this whole thing here, that is your answer. Okay. Hopefully that helps. So go do your homework, and if you have any questions, shoot me an email.